Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now, this might surprise some people because they will probably think it's a ratio of 4 to 1, but we can show here that it's a ratio of 3 to 1. So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 9007000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. This looks like it's a really tricky question, and it is a little bit tricky, but it's a little bit easier than maybe it looks. The highest common factor is found when you have the prime factors, which we do, of two numbers, and you put them into a Venn diagram. Then you can find the prime factor, the highest common factor, by multiplying all the numbers in the overlap. So we're going to rewrite these numbers. Just instead of squared, we're just going to write them out without index form. Just makes it a bit easier. And so I'm just removing the squares, and we're going to draw ourselves a Venn diagram. So let's just do a rectangle at the outside. I'm going to try and do some nice circles here. Try my best anyway. Okay, so on the left hand side we have the 450, on the right hand side we have the 132. So we'll start with the 450 and the numbers. So actually, looking at the numbers, looking at the factors at the top, the prime factors, we can see they both have a 2 in them. So I cross them both out and put 2 in the middle. We can see they both have a 3 in them. So cross those 3's out and put 3 in the middle. And then 450 has a 3, a 5, and a 5. And 132 has the 2 and the 11. So to find the highest common factor, as I said, you multiply all the numbers that are in the middle. And so the highest common factor will be 6. To work out the mass, we will need to find the density and the volume. Density is given to us in the question, but volume isn't. So we need to work out what the volume of this cuboid is. So the volume is just the 33 times the 7 times the 22. So that would be 5,082, and that would be centimeters cubed. And we need to write down the formula for density. So density is the mass divided by the volume. So rearrange this to get mass on its own, because that's the thing we're looking for. So mass equals density times volume. Density is given to us in the question as 2.1 grams per centimetres cubed, times that by the 5082 for the volume, and we get the answer of 10,672. And then that will give us grams, because our density is in grams, so that is grams, but the answer is asking for kilograms. So to convert that to kilograms, we just divide by 1,000 and we get 10.672. Then we need to round that to 2 decimal places, and so that would be 10.67 kilograms. To see if a number's in a sequence, we get the nth term and we get it equal to the number we think is in the sequence. And if the number is in the sequence, then we'll get an integer for n. If the number's not in the sequence, then we'll get a decimal. So we're just solving this now, and we're doing 135 take away 24, which is 111. And then we're going to divide both sides by 10, and you're probably already seeing the fact that it doesn't work exactly, because n is 11.1, which means that Prisha is wrong. 135 can't be in that sequence. There are 2 rules for things to be in direct proportion. The first rule is you must have a straight line, which we do on this question. The second rule is it must go through the origin. So we're looking for a line like this or like that, somewhere in that region there. Now, this red line does not go through the origin, so A and B cannot be in direct proportion. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9:6:13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. So first thing to realise is that the formula for a volume of a cylinder is pi r squared h. So what we need to do first of all is work out the volume of the water butt that James currently has. So we're going to do the volume equals pi times the radius, which is 89 squared, times the height, which is 189. And when we do that, we get 149069 lots of pi. And I'll keep this in terms of pi just for simplicity. Now, what we want is we want the volume to stay the same, so we're going to keep that as the volume, 149069 pi. But we want the radius to change, so instead of the radius being 89, we want the radius to be 103. So times 103 squared, and we're trying to work out what the height is. Okay, so first thing we can do actually is just cross off the pi's from both sides. We don't really need them at all. And then we can get our solving things in, our solving lines, and we can divide both sides by the 103 squared. And on the left hand side we get 141.113 blah blah blah, and on the right hand side we get h. So the height will be 141.113. It says it wants it to 2 decimal places, so that would be 141.11. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the FT, which is just the frequency times the duration of calls. Now in this first group we're not timesing it by 80 to 85 or anything like that, we're timesing it by the midpoint, so our midpoint effectively becomes the T. So we're going to do 15 times that, which will be 1237.5, and we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT. And so we're going to just add this column up here. And so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125, and that's going to be 11.875. Now it does ask for 2 decimal places, so that will be 11.88. So when we're doing column vectors and adding and subtracting them, we just literally add and subtract the top and bottom numbers. So A plus B minus C will be, just looking at the top, 9 plus 18 minus 9, 9 plus 18 minus 9, which will equal 18. And the bottom will be 9 plus minus 18, so really minus 18, and minus 9. And so that will be minus 18. So our column vector will become 18 minus 18. To find the perimeter of this sector, we've got to first of all find out the length of the arc, which will be this part here. And the formula for arc length is, first of all, we find out the fraction of the circle we have. So we put the angle over 360, and that will tell us the fraction of the circle that the sector is. And then all we do is we times that by the circumference, which is pi d. And so that's going to be 49 over 360 times pi times, and the diameter would be twice the radius. The radius is 7, so it would be times 14. When we do all of that, we get 5.986, blah, blah, blah. But that is not the perimeter yet. Perimeter needs to include, get the right ones, needs to include these parts here. So the perimeter will be the 5.986 plus a radius plus another radius. And when we do that, we get 19.986, blah, blah, blah. And we want to round it to 2 decimal places, so that will be 19.99 centimetres. So we're asked to find the bearing of Freetown from Gamley, so that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got a 90 degrees here, we've got a hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out, and we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA, and so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in, and we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434, blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do, but I think this is a really tricky question to do without a Venn diagram. So it says that they picked 2 activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport, so that will go in the middle because that is painting and sport, and 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in, and let's just show it, the total number in the sport circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, so if the painting we label as X, then the sport will be 2X. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2x, take away the 11 that we already know about. And the painting is the same. We know the whole thing is x. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be x minus 11. Now we know that there are 66 students in total. So what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So x minus 11 plus 11 plus 2x minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got x plus 2x, which is 3x. And if I Put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out. So we're left with just the 3x equals, and then 66. We're going to divide that 3 both sides. So we've got x equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of x minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2x minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says, find the amount that picked sport and not painting, which is this 33 here. To find the error interval, I start by just drawing a number line, and we're going to put the number in, so 50.14. And we're going to think to ourselves, well, what would the next number down and the next number up be? Well, it's the nearest hundredth of a gram, so the next number down would be 50.13, and the next number up would be 50.15. Then to find the lower bound and the upper bound, or the highest and lowest it could be, we just find the halfway points between those two. And so the halfway point here is 50.135, and the halfway point here would be 50.145. So the lowest it could be is 50.135, the highest it can be is 50.145, and it asks us to use W for the weight, and we're going to show this with inequalities. Now it can be 50.135, so it's larger than or equal to 50.135, but it can't be 50.145 exactly, otherwise it would round to 50.15, so we don't put the line underneath the inequality. To be able to work out this question, we need to work out the amount of student hours required to paint the wall, and to work that out, we've got 6 students and it takes them 11 hours. So 6 times 11 means it's going to take 66 student hours. So if we had 1 student, it would take 66 hours. 2 students would be half of that because they share the work, and etc, etc. So here we've got 6 students and it take 11 hours, and it says how long will it take 7 students. Well, if there's 66 hours, or student hours, but they're sharing the time, we just divide 66 by 7. So 66 divided by 7 is 9.428, blah, blah, blah. And it says it wants its 2 decimal places, so it will take them 9.43 hours. Now check this makes sense. We've got 6 students and it takes them 11 hours. So we'd think if we had more students helping to paint the wall, it would take less hours. So we've gone from 11 hours to about 9.5. So that sounds right. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4 w to the power 5, it's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4 w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4 w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times 2 powers of the same base and they're both v, then we just add the powers together, so that'd be 8, and we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8 w to the power of 10. So I'm going to write this equation again just a little bit bigger so we can work with it. And one of the rules with equations is you want to get rid of brackets and fractions first. So we've got a big fraction here, and basically a fraction just means divide. So we're doing the 82 and we're dividing it by 3x plus 5. Notice I've put a bracket around it, because what we're going to do is we're going to do the opposite of divide by that bracket. We're going to times both sides by 3x plus 5 to get rid of that fraction. Now on the left hand side that just gets rid of the fraction, so we're just left with 82. On the right hand side, well, we're doing the 2 times the 3x plus 5. Following my rules to get rid of all the brackets first. So 2 times 3x is 6x, 2 times 5 is 10. And you can use any method you want. Some of you might use this method where we've got the 2 here, 3x plus the 5, and then we times them, so it's 6x plus 10. That's how we can do it. Any method you like. And then we're going to take away the 10 both sides because we want x on its own. And so we've got 72 equals 6x. And then we're going to divide both sides by 6. And so we've got 12 equals x, or x equals 12. So to draw a box plot, we need 5 points. We need the lowest point, lower quartile, median, upper quartile, and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17. So we're just going to draw a line at 17. Get it just perfect. There we are. Okay, next thing we're going to look for the lower quartile. So if the median we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12. Fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile. And we do that by adding the 5 and the 10 together to make 15. So we're going to draw a line across from 15 and down. And that's 23. So a line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go. And let's fill in the last bit, join it up with the highest point. And there's our box plot. I'm going to start off by labelling the triangle, and so we've got capital A here, capital B, capital C, and lowercase a, lowercase b, and lowercase c. It doesn't actually matter which way around B and C are, but capital A is always the angle that we're given. So we've got to work out whether we're using cosine rule, sine rule, or something else. Well, here we're given 3 lengths. Well, actually one of them is unknown, but there's 3 lengths involved and an angle, so that's definitely going to be cosine rule. So we're going to write out the cosine rule for when we've got a length, which is the one that starts with a squared. So it's a squared equals b squared plus c squared minus 2bc cos a. And let's fill in the numbers we've got. So that's going to be 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of 22. And when you type that into the calculator, you get 6.184 blah blah blah. But that's what a squared is. So what we need to do now is just quickly solve that by square rooting both sides. And so we get a equals 2.486 blah 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 It says it wants its 2 decimal places, so that's going to be 2.49. So we're going to first of all multiply the coefficient of the x squared and the number on its own together to make our target number. 6 times 6 is 36. And what we're going to have to do is find two numbers that times together to make 36. But we've also got to find two numbers that add together to make the coefficient of the x, so minus 13. So to do that, and just to quickly think it through. So two numbers that add together to make a negative but times together to make a positive, well, they both must be negative. So really here we're only thinking about the negative numbers. So let's write down the factors that we know. So minus 1, minus 36, minus 2 is minus 18, minus 3 and minus 12, minus 4 and minus 9, and minus 6 and minus 6. So we're looking for the numbers that add together to make minus 13. So just looking down the list, I think it's going to be minus 4 and minus 9, which is correct. So the two numbers are going to be minus 4 and minus 9. And so what I'm going to do is rewrite the question, but instead of that minus 13x, I'm going to replace it with the minus 4 and minus 9. It doesn't really matter which way around we do them. So we can do them as minus 9x minus 4x. It really doesn't matter which way around we do them. So we're going to look at the first two terms, and we're going to factorise those linearly. And we're going to look at the second two terms, and we're going to factorise those linearly. So putting my bracket down, we actually realise that we can do a 3x here. And sometimes it's mostly just an x actually. In my experience, I think I just put them in size order normally. So we've got 2x here, and then that would be 9 divided by 3 is 3, and then x divided by x is 1. And now here, there's a negative here, so we must have the negative on the outside, and 4x and 6 will be 2. So we're going to divide out the minus 2, so that would be positive 2x. Now we've got to be careful here, because what times minus 2 is 6? Well, it's going to be minus 3. Next, notice that the two brackets here and here are the same. If they're not the same, you've done something wrong, because they have to be the same, and we write them down once. And then the bits left over outside the bracket, we also write a bracket with those down, so 3x and minus 2. So our answer is 3x minus 2 in the first bracket and 2x minus 3 in the second bracket, but the brackets can be the other way around. To find the distance or displacement on a velocity time graph, we're actually going to find the area underneath the graph. And to do that, we're going to split the graph into two. And we've got the trapezium on the left-hand side, and we've got this rectangle on the right-hand side. So to work out the area of the trapezium, we're going to do half a plus b times the height. And the two parallel sides are on the left and the right. So it's going to be half times this part here, which is 40, plus this point here, which is 160. And then the height is actually the width. So the height is this bit here, so that's going to be times 2. Those will cancel out, the half and the times 2, so that would be 200. And similarly, to work out the area of B, it's just length, width times length. So that's going to be 3 wide. And again 160 tall, so 3 times 160, which would be 480. And so we need to work out the total area, and we do that just by adding the two together. So 200 plus 480, which will be 680. I'm going to start by identifying the equations of each line. So here we've got y equals 2, because the y coordinate is always 2 on this line. This one here we've got x equals minus 3, because the x coordinate is always minus 3. And this next one is a bit more difficult, but it's perfectly diagonal, so it's going to be a y equals x line. But if you look, it crosses the y-axis at minus 1, so it's going to be y equals x minus 1. Okay, these are not inequalities though, so we need to work out what the inequalities are. So we're looking at the region which is here, and we can pick a point in the region. I normally try and pick a nice easy one, so let's pick 0, 4. So 0, 4 is in our region. So 0, 4, let's compare that to our y equals 2. Well, what is that compared to 2? Well, it's actually greater than 2. So it's y is greater than 2. We have a look, the fact that our line is dashed, it's not going to be equal to 2, because it's saying it's not on that line. Okay, this next one, let's have a look at this. Well, is it greater? Is that 0 greater than minus 3? Well, yes, it is. So it's going to be x is greater than minus 3. Again, the line is dashed, so it can't be on the line. Now, this last one's a bit more difficult, because it's got x and y in it. So we feed in the values. So for our coordinate that we've picked, x is 0 and y is 4. So 4, and I'm just going to put, I don't know, not equal to, but or I'm just going to leave that blank, leave that as a box. And 0 minus 1. So all I've done is fed in the coordinate values into this equation. And I've got rid of the equals, because what we need to do is work out what inequality it's going to be. 0 take away 1 is minus 0. So what is 4 compared to minus 1? Well, 4 is definitely greater than minus 1. So it's going to be y is greater than x minus 1. But if you look, this line is solid. It's a solid line. It's not a dashed line. Therefore, we're going to put a little line underneath it, because it can equal it as well. I'm going to start by labeling this triangle, and so I'm going to pick a lowercase a here, uppercase A I mean, for the angle, and then we go opposite it to mark the length with a lowercase a. I'm going to do a capital B here, and then go opposite it to do a lowercase b, and then obviously a capital C here, and then a lowercase c here. Now notice the c's aren't involved in this question at all. It's just the capital A and the lowercase a, and the capital B and the lowercase b. Now when you've got two pairs of angles and sides, you're going to be using the sine rule. Now, the sine rule is either sine A over A, or it's A over sine A. Now, when we're looking for a length, we put the length on the top. So it's going to be lowercase a over sine capital A equals lowercase b over sine capital B. Okay, so we're going to fill in the values. So A is x, capital A is 38, lowercase b is 4, and uppercase B is 67. Now you'll only ever sine an angle, so if you ever put a 4 in there or something, that's not going to be right straight away. Okay, let's work out what 4 over sine 67 is, and that's 4.345, blah blah blah. So we're going to solve this. It's going to be a nice and easy solve today, because all we need to do is times both sides by sine 38. And so that will give us 2.675, blah blah blah. And when we round that, we get 2.68. So we're told that the two cuboids are similar, which means we can have scale factor, and we can work out the linear scale factor straight away to find out what we times the 14 by to get to the 49. We're going to do 49 divided by 14, big one divided by small one, and that gives us 14, does it? No, 3.5. Okay, so we times it by 3.5. So 14 times 3.5 is 49. But that is the linear scale factor. And this question is all about volumes. So we're looking at going from here to the volume of the smaller one. Okay. So whenever we go from the bigger to the smaller, we're going to divide by the scale factor. So we know we've got to find the scale factor and divide by it. but the volume scale factor is going to equal the linear scale factor cubed, because volume scale factor has 3 dimensions. Volume has 3 dimensions, therefore it's going to do the linear scale factor 3 times in a row, times 3.5, times 3.5, times 3.5, or 3.5 cubed. So the volume scale factor, we're just going to cube that 3.5, and we get 42.875. So it'd be 42.875. And so on our calculator, we're going to do 4,201.75 divided by the 42.875, and we get the answer 98. Whenever you're asked to work out a proportion of items in a histogram, you can actually do it by just counting the squares. So in the first bar, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 squares here. The next one, you've got kind of 4 half squares, so that will be 2 squares in total. And then we've got 4 squares in the last one. So altogether we have, for the amount of squares, we have 12 plus 2 plus 4, which will be 18. So it's 18 squares in total. Now it says that we're looking for between 25, which will be here, and 45, which will be here. So we count the squares in this little interval. So there are 3 here, and there's half a 1 here. So the squares between 25 and 45, I should say dash 45, 25 to 45 is 3.5. Okay, so we've got 3.5 in total, or 3.5 out of a possible 18. So we just need to do 3.5 divided by 18 to work out the proportion, and that gives us 0.194 blah blah blah. It says it wants its 2 decimal places, that would be 0.19. So we're going to just quickly write out our sequence, so 9, 22, 41, 66 and 97, and we're going to find the differences of each of them. So that's going to be plus 13, then we've got plus 19, so they're different already, we know that it's not a linear sequence, and that's going to be plus 31. So we now look at the difference of the differences. And so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence. And we're interested in what the difference of differences is, because what we now do is get that 6, and we always halve it, and it gives us 3. Now that 3 is actually really important, because that is the coefficient of the n squared. So we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth and fifth. So 1, 2, 3, 4, 5. The sequence is just 9, 22, 41, 66 and 97. Now we know that 3n squared is part of our sequence, so what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3, 3 times 2 squared, which will be 12, and then 3 times 3 squared, 27, 3 times 4 squared, 48, 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit, because we know what that is. We've already answered that part. So 9 take away 3 is 6. 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now what do you notice? Well, we notice that these ones here are going up in 4s. So we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. and then we find the 0th term, so we go back, so 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. In this question, it might be easier just to draw a quick diagram. So let's draw this equilateral triangle, and it says that its lengths are all 10 centimeters. And we're looking to find the area. Now, we also know with an equilateral triangle, all the angles are 60 degrees. So we can plot those, but we don't need to plot them all. We can just plot one of them. And we know that to find the area of a triangle, we can use this formula here, which is half AB sine capital C. And if we have a look at this diagram, we can label the sides. So I'll call this side, this angle C, and little c here, and little a here, and little b here. So let's put that into our formula. Little a is 10, little b is 10, and sine c, which is 60. So with a, b and c, it doesn't matter what you label a, b and c, as long as the angle is opposite the side with the same letter. The angles are all capital letters, the lengths are all lowercase. Okay, so let's put that into our calculator, and we get the answer of 43.301, blah blah blah. It says it wants it to 2 decimal places, so that is 43.3. So I'm going to first of all just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put little notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. Let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A. And then we've got the 1/5 B. So it's going to be 4/5 A plus 1/5 B. To solve when we've got two equations that aren't linear, and here we've got a linear and a circle equation, what we're going to do is we're going to solve by substitution. We're going to substitute one into the other. So here we're told that y is equal to 3x plus 11, and we actually have a y in our second equation. So what we're going to do is just substitute it in. So we've got x squared plus, and instead of y, I'm going to say what the first equation is. I'm just going to replace it for what y equals in the first equation, which is 3x plus 11. And it's y squared, so it's that squared, equals 125. Okay. Now we need to expand the brackets there. And so we're going to have x squared, and you can use any method you want. And don't forget, when you square brackets, that's just going to be 3x plus 11 brackets 3x plus 11. So we're going to do 3x squared, which is 9x. So how are we going to write this? So plus 9x squared. And then we've got 3x times 11 plus 3x times 11, which is 33x plus 33x, which is 66x. And then we've got 11 times 11, which is 121. Now at this point, we want everything to equal 0 because it is a quadratic. So to solve it, we need it to equal 0. So we're just going to tidy it up and add the bits that need to be added. And we're also going to subtract 125 both sides to get it equal to 0. So x squared plus 9x squared is going to be 10x squared. So we might as well just write it as 10x squared. We've got 66x just on its own. And we've got 121, take away 125, which is minus 4, equal to 0. Now it says it wants our answers to 2 decimal places, so chances are these won't factorise nicely, so we're going to be using the quadratic formula. And so we need to find out what a, b and c are. So a is the number before the x squared, the coefficient of the x squared, which is 10. B is the coefficient of the x, which is 66. And c is the number on its own at the end, which is minus 4. The quadratic formula will be minus b, and I always put the values we substitute into brackets, because if they're negative, that really helps us. Plus minus square root of b squared minus 4 times a times c, all of that over 2 times a. When you put that as a plus, then into the calculator, we get x equals 0.060 blah blah blah, and when you put a minus there, we get the answer of minus 6.660 blah blah blah. Now you might think, well, how are we going to find out what the y's are? Well, if x is 0.06 blah blah blah, we've got an equation here that says to find out what y is, we times the x by 3 and we add 11. So we're going to times that first solution by 3, then add 11, and that gives us that y is 11.180 blah blah blah. We're going to do that with the next solution, and we're going to times it by 3 and add 11, and when we do that we get minus 8.980 blah blah blah. We're going to round each of these to 2 decimal places, so we've got 0.06 and 11.18, and the second set of solutions is minus 6.66 and y equals minus 8.98.
You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.